All right, guys, let's go over the conclusions of the Blocking Dogs Lab. And so this is 7th period's data, and I'm just going to go ahead and give that to you, and we'll take a look at that. So here, this is 2025, 2026 data. So let's take a look. We had done 3 experiments: the completely randomized, the blocked by breed, and the blocked by clinic. So you did this, you put this data in, and then I graphed it. You put all these numbers in. So let's take a closer look at what we have going on. So first of all, remember that what we did with our completely randomized was we just had all the dogs in a bag. Okay, so all the dogs in a bag, and then we did that random assignment. And so when we did that random assignment, let's see, I'll pull this thing over. So we just then, in fact, I have it SRAPME capped written out here. Start with the 24 randomly selected dogs. Randomly assign the dogs to a treatment by putting them in the big bag. Shake well. And without replacement, pull 8 dogs to the exercise and calcium group, 8 dogs to the calcium only group, and 8 dogs to the control group. All right, measure each dog's bone density change. Remember, his bone density change. And then we want to compare the average bone density change of the dogs in the 3 different treatment groups to see which treatment reduced the bone density loss. Okay, so that was the completely randomized experiment. Just everybody in the bag, shake well, and do her thing. So let's go ahead and take a look at these results. Let's take a little closer look. So here we go. Here is our data. And I want you to think that over here to the left, then we're getting more bone density loss, okay? And I think you understood that yesterday when you were doing the lab. So this is more loss over here. And then on the right-hand side, this is less bone density loss. Okay, so I want us to answer some questions. And, I don't know what page this is. I think it might be page 45 in your packet. So let's take a look at that. All right, so the first question being, is there a clear difference in these 3 different treatments? So just to clarify, you can see these dots are the blue dots are the exercise treatment and how much bone density loss those dogs had. Okay, the red dots was the calcium only and how much bone density loss those dogs had. And the black dots are the control group. All right, so do you see much difference in what these dogs were experiencing? I see blue, red, black dots all across the spectrum of the different bone density losses. So I do not see much of a difference. They pretty much overlap. Okay, so no clear central location for the data. All right, well, how about the spread, the variability? How closely clustered are the data to themselves? Are the blacks, the control group dogs grouped together? Are the exercise group dogs grouped together and the calcium dogs grouped together? Well, clearly not. They are so spread out, quite a wide range. So they are so spread out that all the treatments overlap. They're very spread out. I can't see a clear winner in the treatments. Okay, so that's a big deal. We did not have any control and the data was all over the place, no clear center and no reduced variability. All right, so now let's take a look at our second information. This one is where we thought that breed might impact what we're doing. So we wanted to control that. So we are only comparing Akitas to Akitas. So let's look at this design. It's super important. First, you take all the dogs, but before you do any random assignment, you block by breed. So we blocked by breed because we thought breed might impact what we're measuring. Then the Akitas went in a bag. So we had the Akitas in a bag. Let me get this here. So we had the Akitas in a bag. We had the Beagles in a bag. And then we had the Collies in a bag. And then we had the Dalmatians. Sorry, my bags aren't very good looking there. And so we then also, once we had the animals in a bag, remember I went around the room, and we had 4 miniature experiments going on. We had the Akita experiment, the Collie experiment, the Beagle experiment. Once we had them in their own breed's bag, we did random assignment to the treatment. So I want you to notice here at the end, it's important. Notice I will only be comparing Akitas to Akitas, and I will only be comparing collies to collies, and so on. We do not then say, I'm going to compare them after that. No, we blocked by breed, so we don't compare with different breeds. Okay, so I want to show you how the Strapmi-Capt morphs into a Brabratmi-Capt. Okay, so let's take a look at that. So, let's see, hold on a second. Here it is. Okay, so the b-b, I know you love that. The b-b at the beginning is block by, and then what you're blocking by, breed, because, so here's the b-b, the block by this trait, because this trait may affect bone density loss, what you're measuring. So this is whatever trait you have, because that trait may affect what we're measuring. All right, now here's the interesting thing. Here's going to save you a whole lot of work if you catch what's happening. So I start my experimental design with saying how I blocked. Block by breed, because breed may affect the bone density loss. Now, inside of this experiment, this design, I'm going to do one Strapmi-Capt. Start with the Akita block of dogs. So look at this Strapmi-Capt that I did. Start with the Akita block of dogs, randomly assign them, do all the things. In fact, I literally copied and pasted this blue section from the first Strapmi-Capt, and then I just put in that we're doing the Akitas and not just all dogs. Okay, so that Strapmi-Capt is literally the same words as I did in the first Strapmi-Capt, but it's just with Akitas. Now, we've only done Akitas here. You do not need to say this a whole bunch more times, but you have to say this. Repeat the above experiment with the Beagles, Collies, and Dalmatians. So once you do that, now you have described all of the Brabratmi-Capt. Okay? Block by breed, because the breed may affect bone density loss. Strapmi-Capt with one of your blocks, and then repeat in the other box. Done. That's how you do writing out a blocked experimental design. Okay? And I had you pick up the papers when you came in, and I'll show you that here in a second. But let's take a look at our data and see what blocking did for us. Remember yesterday in class, I explained how we got the breed average, and then I took your raw data for Akitas, and I subtracted out the Akita value, and these are what remained, okay? And I graphed those. And again, remember that the exercise and calcium were the blue dots, the calcium was the red dots, and then I can't get my finger small enough to do that. So the calcium were the red dots, okay? And then the control was the black dots. All right, look at these dots. Once again, further to the left, this right here is more loss, and then over here to the right, we had less bone density loss, okay? Look at those colors. Very different looking than our completely randomized. So let's go on down here and answer then our same questions, but for the blocked. So I think we're now on page 46. So here we go. Is there a clear center for the 3 different treatments? Well, I can see, the black dots, the control group is centered somewhere around maybe -6. Now, the red and the blue seem to be kind of in the same general vicinity, so they're probably centered here around 3 or so. So all I really can say is the control seems to be centered much lower. I could get technical and put the numbers there, okay? But just for quickness here, I'm not going to do that. How about the spread? Remember on our other one, the dots were all over. The range of those dots was huge. It went from way positives to way negatives. In fact, let's look at that real quick. Look, well, actually, they were all negative. I'm going from negative 60 down to negative 160. So large spread. Look at the spread here, negative 10 to positive 8. So much less spread, that I can see that the control groups are grouped together and they are clearly lower than all of the exercise and calcium treatment groups. So that's a big deal. That is huge. So here's how that reads. Much less variability in the data. Therefore, I can see that the control group dogs all had more bone density loss than the other two treatments. Okay? Way different results because we took the breed component out. All right, we controlled the breed. Now, let's take a look at our blocked by clinic. So again, when you have a blocked by clinic, you start with all your dogs and the first thing you do is block by clinic because I think clinic might impact what I'm measuring. Okay, that's the start, and that's also the start of how you write up a blocked design. Block by clinic because I think clinic may affect bone density loss. All right, now then within each of these, this is a bag, a paw prints bag, I'm going to randomly assign to the treatments. So now each separate block does their own miniature experiment and they all get randomly assigned. So let's read that experimental design for the clinics. Here we go. Block by clinic because, well, I don't know why it says care, but because the clinic may affect bone density loss. And then I SRAP-me-catted. Start with the 8 blocked dogs from paw prints. So now I'm just describing a SRAP-me-cat with the paw prints. Straight all the SRAP-me-cat, literally I copied it from the other SRAP-me-cat and I just replaced, instead of dogs, I put paw prints dogs. And to finish it out, repeat the above experiment with the Pooch Palace, Treehouse, and Barking Lot clinics. Okay, so that's how you do a SRAP-me-cat. So let's now come on over here and see what our results look like. Okay, so here was, again, here, remember how this worked. Here is the paw prints average bone density loss at that clinic, and when I took that out, here are my results. I took out the Pooch Palace average bone density loss, and I had all these results, and look at these. Again, exercise and calcium was blue, calcium only was red, and control was black. Look at those dots. What is interesting about those? Again, center. Where are they centered, and what about their spread? Let's take a look at those things. Here we go. Can you tell a clear difference in where the 3 different treatment groups are centered? No. This looks more like our first one, our completely randomized. Okay? Now, let's take a look at this. How about the variability? The data in each treatment still overlap. We still have quite a bit variability going from negative 45 up to positive 30. So that's not as much variability as our first experiment. Not as much, it's less, but it's not as reduced variability as the blocking by breed. So the data still overlaps. It is difficult to see a clear difference in the treatments. All right, so that's the big idea, is that the blocking reduced the variability. It reduced it a little with the clinic. It reduced it a lot with the blocking by breed, okay? In fact, that's going to lead into our next questions we asked, which is this. Is there an experimental design that allows you to see the differences in the effectiveness of the treatments? I think you know that one, definitely, blocking by breed. How about the designs? What about that design scheme that made it easier to see the differences in the treatment results? I've mentioned this several times. Did you catch it? The data was more closely clustered together. So we had a lot mostly clustered together, and the treatments did not overlap, or the control did not overlap with the other treatments. More closely clustered together, okay? Clinic was better than completely randomized, but breed was better than clinic. All right, so the question then is, what's the purpose of blocking? Well, the thing that made the difference is that it reduced the variability. It made the data more closely cluster to its where it was its central effect, reduced the variability, and there's a song about that. Next question. How do you know going into a problem if you should block? Okay, if you think that there's a confounding variable that you need to control, that's when you should consider this, all right? In the AP world, they will probably allude to another type of trait that there might be confounding issues with, okay? So you think you should, if there's a trait that can impact the response you are measuring, okay? If there's a trait that can impact the response you're measuring. Now, in our case, how did we know which was the better trait to block by, breed or clinic? Well, in our experiment, I just kind of showed you that breed reduced the variability more, okay? But I suspect that if we were given the option without even doing this data, between which thing do you think impacts bone density loss more, breed or clinic? I bet you most of you would pick breed. We kind of talked about size of dog, genetics of dog, that kind of thing. Probably has a much bigger difference than any clinic influence in the diet and stuff. So the answer is, it's a clear answer that you support and you decide based on you should block by the trait that you think has the biggest impact on the response that you are measuring. So that will be the answer. If College Board asks you, how do you decide which way to block? Your answer is, I choose this way, because I think this trait impacts what I'm measuring, and you say what that is the most. Okay, there it is. All right, so that is the summary of the Blocked by Breed Lab. I'm not going to play this song today. We'll get that when we get back from break, okay? So goes to the good vibrations, and we'll take a look at that. See, you can see you're making homogeneous groups, so blocking reduces variation, and within each block is experimentation. Within each block, you make your own experiment. Okay, so done with the Blocking Dogs Lab. Now, you picked up when you came in this page here, and I want you to read through it. It's the bipolar disorder problem that we've had before, and we were measuring bipolar symptom improvement, okay? It was on a scale this time. It wasn't the patients were asked. It was on a scale. But here's what was new. I added this to the problem. Suppose that some of the 30 subjects were very active who walked a lot or got very vigorous exercise several times a week, while others tended to be more sedentary. They worked office jobs, they watched a lot of TV, so they weren't as active. Do you think activity level could impact how you feel? I think a lot of you probably know that. So that was alluding to you that that might be a confounding variable. So take a look here in this question here. Let's talk through this and then I'll show you the design real quickly. Suppose that, okay, if you designed this as a completely randomized, like we did with the dogs, and just everybody went in the bag and we shook well and then we did them to the omega-3 or the placebo. What could happen that would make it difficult to tell the true effects? So here's an example. Suppose that most of the active patients got the omega-3, okay? Then if you saw major improvement with this group, you didn't know if it was because of the omega-3 or if it was because of the exercise that they were getting, okay? So you couldn't see the clear effects of just the omega-3. That's why I need to choose to block. So look at, I'm going to pull this out here so you can see the full page. So here is the design, this first section here. Block by activity level, and then I described it. The activity level was, I'm going to choose active and sedentary, okay? Because it is known that activity level can affect bipolar symptoms. All right, so there was my reasoning, and there also I tell you what groups I'm going to do, what blocks I'm going to do. Now, look, I'm going to strap me capped with bipolar patients, with the active ones right here. Start with the active bipolar patients. Okay, one last thing before I let you go. How many active patients are there? There's 30 total patients. Do we know there are 15 active and 15 sedentary? No, we do not. Now with the blocking dogs, it was designed so we knew the number of each dog and each clinic and stuff. But not here. We do not. Notice that the number of patients in each group is unknown. So I just could say start with the active bipolar patients, however many that is. Watch how I handle that. Randomly assign them to a treatment by putting them in a bag, shake well. Without replacement, pull half of them. See, I don't know the number. Half of the active patients and put them in the omega-3 group and the other half of the active patients in the placebo group. Okay? That's how you handle unknown numbers. And then we continue, measure each patient's symptoms on a scale of 1 to 10, compare all the things, and finish out with repeat the above experiment with the sedentary bipolar patients. Repeat with the other, now you're done. Okay, so you are going to do 2 homework pages. I don't know those numbers right off the bat, but they are 2 scenarios where you read it and you do the brat me capped. And you have this paper to help you. And so you know what though? I hear Cookie barking, or no, maybe it's Pumpkin. I think it's Cookie. I'm gonna bring them in here. If you have time here at the end, here we go. Let me see if I can get the dogs. Cookie, Pumpkin, come here. Here comes Pumpkin, oh my gosh. Oh, and Cookie, okay, I'll show you. Here we go. Okay, here's Cookie. Here's Cookie, she's so cute. Okay. Here's our Cocker Spaniel Cookie and our Pumpkin. Here's our Cocker Spaniel Pumpkin, and then here, let me get you Cookie. Come here, Cookie. She is thick. Oh my gosh. Let's go, Cookie. Here we go. Here is Cookie. Oh my goodness. Pumpkin is jealous. Pumpkin's jealous. Okay, there's Cookie. Okay. All right. So there's your Blocking Dogs lab. I hope you understand a blocked design and that you can practice that on your own. All right, good luck with that.